Okay, hello. So today we're looking at question 3 to 8 odd even linked list. Given the head of a singly linked list, group all the nodes with odd indices together, followed by the nodes with even indices, and return the reordered list. So first node is odd, second node is even, and so on. And we should retain the relative order inside both the odd and even groups. And we have to solve the problem with in linear time and with constant extra space complexity. So example 1, 1, 2, 3, 4, 5, because we kind of want to move the odd numbered nodes to the first half of the list, and then the even nodes to the second half. We return 1, 3, 5, 2, 4. And example 2, we have the odd numbered nodes are 2, 3, 6, 7. So we want to return 2, 3, 6, 7, and then 1, 5, 4. So here are some constraints. The number of nodes in the linked list can be 0, ranges from 0 to 10 to the power of 4, and the node values ranges from minus 10 to the power of 6 to 10 to the power of 6. Okay, so I actually tried this question earlier, like on a whiteboard, and I looked at a few solutions in the discussion section, and I did find one that's like super concise and clear. So I will be sharing that solution and also be linking that solutions link in the description box below. Yeah, okay. So if we have something like, so I guess we can just start off by thinking like what kind of examples we can get. So the two, other than the list being empty, the other situations are basically if the number of nodes in the linked list, if it's odd or even numbered, right? So that's the first case is like that, and the second case is something like that. 4, 5, 6. Okay, so how this question works is we can basically initialize 2 pointers first, odd and maybe a different color, even. And then as we traverse down the linked list, what we want to do is basically set this odds dot next to its dot next. So it points to here, and then so that means this is gone. And then the evens turn, we basically want to set it dot next to dot next, and then this will be gone. And then we move it to the correct node, the correct position. So for the odd, it'll be moved here, even, it'll be moved here. And then we keep going until even ends up as none, or its dot next is none. So the question is, how do we know that we traverse until like even is none and even's dot next is none? Like, why can't it be odd none and odd dot next is none, right? So if we think about it this way, like, because even is the one that's like always kind of like ahead in a sense of the odd one. So if our condition is instead of even, if it's we check for odd, it might be we might face a situation where like there is no more like dot next for it to go to, for the even to go to, right? Yeah, so that's the reason why our while loop condition is the checking for even or even and even dot next. So second time we do, so at this point in time we do one more, right? Because even is exists, and dot next also there's a node here. So for even we go here, and this is our terminating condition. So let's illustrate this whole flow with the odd even numbered linked list now. So we go 1, and then like over here, and then this node dot next we reach here, and over here we go here. So we can see that in this case we also like finish because the evens dot next is none. So we can clearly see in this example that if we check instead for the odd, like check if while odd and odd dot next, we will continue doing another round and cause our even pointer to point to something like dot none's dot next, which is clearly like will result in an error. So we don't want to do that. Okay, so this much after this after traversing through the linked list like that, we now have even nodes and then odd nodes, right? In even indexed nodes and odd indexed nodes. So but the problem is that we lost where like so if you remember, we do have like a head pointer, right, keeping track of where our odd nodes odd indexed nodes start, but we lost the even indexed node, like the first even indexed node, which is in this case 2, because well this link is broken, right? So we have to remember to set a pointer here as well, first even, so that we can at the end when odd is here point odds dot next to the first even, and then we return the head. So let's see, like we have to declare, basically work with these 3 pointers. Okay, so now let's try implementing this solution. So declaring them first, right? So odd is head, even pointer. Okay, and remember how we said like we have to have a first even as well. So first even, also just even key. Okay, now we do something like while even and even p dot next. We want to go down the traverse down the nodes, right? So let's think. To do that, we first figure out where it's supposed to go next. So odd dot next, and then same for even. Okay, now we kind of like, now we have this odd dot next. We move the odd pointer to the correct spot, and same for even. Oh, I missed the P. Okay. And then once that's done, we have to kind of like move the odd pointers dot next to the first even, right? Yeah, I think so. Okay, then we return head. Okay, let's see if this will work. Okay. So non-type objects, not sure. So head, in this case, it's an empty linked list. This will result in an error, non-type error. So we can have like a condition that catches that before. If return what? Head? Wait, hang on. So in this case, what should I return? If it's empty. Okay. So if it's 0 nodes and if it's 1 node, then we can just return the head directly, right? Is that correct? If not, head or next none. Can we do, is this what they want? Oh, okay, sweet. So that is it for today's LeetCode question walkthrough for 3 to 8 odd even linked list. Yep, thank you.